So, looking at some calculations. Now here are a few basic principles to remember. We have a stoichiometry for our equation. Now I've written this as a 2 moles of P plus 1 mole of Q are in equilibrium with 3 moles of R plus 1 mole of S. That 2 to 1 to 3 to 1 ratio is fixed by nature, if you like. The stoichiometry is the stoichiometry. We have that particular ratio for that particular reaction. There's nothing we can do about that. But what we can do is we can decide how much of each of the reactants and products that we begin with, our initial number of moles. So in this particular case, I'm saying we'll start with 1 mole of P to 2 moles of Q and not have any of R or S. But there's no reason why we couldn't have some R or S in there to begin with. Those blue numbers hold no relationship to the red numbers, notice. But when the reaction comes to equilibrium, then that is a different matter. Because the equilibrium amount will depend upon the stoichiometry and of course the initial amounts that we have. We will tend to lose the proportions, the relative proportions of reactants based upon the stoichiometry and gain the amount of products again based upon the stoichiometry. Okay, so we're looking at this equilibrium calculation. When 1 mole of ethanoic acid is mixed with 1 mole of ethanol at a fixed temperature, 0.66 moles of ethyl ethanoate are formed at equilibrium when the total volume is 0.1 cubic decimeters. Calculate the equilibrium concentrations of the reactants and calculate Kc. So let's start by writing our balanced equation. Ethanoic acid, CH3 CO2H, reacting with ethanol, CH3 CH2OH, going to ethyl ethanoate, CH3 CO2 C2H5 plus water. Now we can see that we've got a 1 to 1 to 1 to 1 stoichiometry or ratio, molar ratio, and therefore let's just see what we've got, and that in terms of the initial number of moles. Our initial number of moles, well, we know that we start with 1 mole of ethanoic acid and 1 mole of ethanol. We haven't got any ethyl ethanoate or water to begin with. Okay, now when this reaction comes to equilibrium, because we have a 1 to 1 ratio, we will lose the same amounts of ethanol and ethanoic acid. So let's put that as X. So we're going to lose X moles of ethanoic acid and we're going to lose X moles of ethanol. And because it's a 1 to 1 ratio on the product side, we're going to form the same amount of ethyl ethanoate and water. So we have a 1 minus X, 1 minus X, X and X. Now we know the equilibrium number of moles of ethyl ethanoate because we're given that. That's 0.66. So therefore we must be getting the same amount of water, 0.66. And to have that happen, we must have lost 0.66 moles of ethanoic acid and 0.66 moles of ethanol. And of course, if I do my quick calculation, 1 minus 0.66 equals 0.34. So we can say that the number of moles of ethanoic acid at equilibrium is going to be equal to 0.34. The number of moles of ethanol at equilibrium is going to be equal to 0.34. The number of moles of ethyl ethanoate at equilibrium 0.66, and the number of moles of water at equilibrium is going to be equal to 0.66. So that's fairly straightforward. So our concentrations of ethanoic acid is going to be the number of moles over our volume. Well, our volume is 0.1 cubic decimeters, which is 3.4 moles per cubic decimeters. Of course, the concentration of sorry, that was ethanol there, wasn't it? CH3 CH2OH. is the same, 3.4. The concentration of our ethyl ethanoate, I'll just call that ester if you don't mind, is going to be equal to 6.6, and the concentration of water is also 6.6. So therefore we've got our concentration values. Now, second step is to work out our Kc. So we've got our equilibrium concentrations that we were asked to get. Now our Kc, nice and straightforward. Kc is equal to the concentration of the products over the reactants. Let's have a look. There are our products, water and the ethyl ethanoate. So we've got CH3 CH2CH3, the ester, concentration of water over the concentration of ethanol, CH3 CH2OH, concentration of ethanoic acid, CH3 CO2H, like that. And we just put our values in. Concentration of our ethyl ethanoate, 6.6 times 6.6 divided by 3.4 times 3.4. If I do that on my calculator very quickly, 6.6 I'll make that 3.77. Let's make that 3.8 then. And the units, well, you'll notice here that we've got the same number of moles on both sides, and therefore the units cancel out.